back. This is Math 200. We're looking at the test review for chapter 5 and 6. So this is going to predominantly be factoring. 17 and 18 and 19 and 20 have a little bit of division, but then we're going to start factoring on 22. So the last 10 to 14 problems will be factoring. So we're on number 17 of the review. That's page 4 in the review packet. And you got x to the third plus 5y quantity squared. So what I suggest you do with this, it's a binomial. Write it out twice. And then just do it like how you always do binomials. Do the distributive property twice, or FOIL, if you like to call it first letter and last. So x to the third times x to the third is x to the sixth. So x to the third times 5y is 5x cubed y plus 5x cubed y plus 25y squared. Now, students ask all the time, wait, I have yx cubed instead of x cubed y. It's fine, either way. Either way is fine. Order doesn't matter with multiplication, remember. Commutative property, you can switch them around. But whatever way you decide, do it on both of them so you remember that those are like terms and you can combine them. So we have x to the sixth plus 10 x cubed y plus 25 y squared. Also, be very careful not to change the powers. Remember, when you combine like terms, you don't change the powers, you only change the number in front, the coefficient. Remember, that's how it worked. When you had 3x plus 5x, that was just 8x. You didn't write 8x squared. You never change the power unless you're multiplying. See, x to the third times x to the third, that changed the power. Then I added the exponents. All right? So you got to keep your ducks in a row when you're doing these problems. 18, we got negative 112 c cubed d cubed plus 70 cd squared plus 42d. And all of that is being divided by negative 7. And so basically, because this is a monomial, I can just write it underneath each term and then reduce. So this one, hopefully, will be a quick one. Remember, you get to use a calculator on every test, so you got that. You don't have to worry about dividing by hand. Negative 112 divided by negative 7 is positive 16. It's still c cubed d cubed minus 10 cd squared and minus 6d. Okie dokie. Awesome possum. I'm going to bust out the blue and red for the next one. It's long divide. So we're going to long divide 2 times here. So let's take a look at this long division problem. And we do this just like how we long divided like in the past with numbers, when we're working with numbers. Let's do a real quick one. 563 divided by 4, we'll say. So remember how that worked. You went, 4 goes into 5 once, so put the 1 there, but then you did 1 times 4, and you wrote it down, and then you subtracted it. You got 16. And then you went 4 times what gives me 16, and that was 4. So 4 times 4 is 16. You wrote it down, you subtracted it, and then you would bring down the 3, and 4 can't go in the 3, so that's the remainder, so you put a 0 there. And then you used to go R3, but we're not going to do that. We're going to say plus, and then whatever that is, over what's being divided. What you're dividing, what is that? The divisor, this is the divisor, this is the dividend, this is the quotient, I think, is the fancy math terms. So 140 plus 3/4. So that is basically what we're going to do. We're going to follow that same process, but we're going to do it with these abstract numbers with variables in here. And second degree, a second degree trinomial divided by a first degree binomial, very fancy. So you ask yourself, what do I multiply x by so it exactly matches 3x squared? All right, and that would be 3x. So you write a 3x there, 3x here, you multiply it, you get 3x squared minus 6x, and now the first term should always cancel away. If it doesn't, then you did it wrong. You've got to pick it to multiply it by whatever is going to make it match that exactly, okay? So, but then remember, I subtracted and I subtracted. So here, I'm going to make a big old minus, and then because that is a minus, I'm going to make a big old plus. So I'm going to change the signs of both of those, because remember how the distributive property works. If I had 3x squared minus 6x like this, and I threw a negative in front of it, I would distribute that to both and get negative 3x squared plus 6x. That's why I changed both signs. All right. Then I add straight down. The first one cancels away. It always should. I got negative 11, positive 6. That's negative 5x. I bring down the plus 10. And now I start over like it's a brand new problem. So x times what gives me negative 5x. I want it to match exactly. So that would be a negative 5. So then I multiply it by that, do the distributive property, negative 5x plus 10, sweet. And that turns into a plus, that turns into a minus. And then that goes away, and that goes away. So this is the quotient. That's it. And it's just 3x. Minus 5 is the answer. No remainder, like that one. Okay? Number 20. Same dog, different fleas. Let's take a look at it. We got y plus 1 into y squared minus 8y plus 12. Okay, and so again, I play the same game. What do I multiply y by so it exactly matches y squared? That would be a y. I'm putting it here just like how when I long divided, I put it there. Really, it doesn't matter where you put it, I guess. This one's up there somewhere. This one. So y squared plus 1y. And then remember, I subtract both of them. So this goes away. This is sort of like collateral damage. I didn't really expect it to go away. So it made negative 8, negative 1, that's negative 9y. And then I bring down the plus 12, and now I start all over, reset. Y times what gives me negative 9y. So that would be a negative 9. I'd write that down, y plus 1. Do the distributive property, negative 9y minus 9. And change both signs. And so I end up with 21 as a remainder. And so now for my answer, I'm going to say plus 21 over y plus 1. So that is the remainder. All right. Okay. Good for time, 8 minutes. All right, so now let's switch gears into the word problems. So this is a pretty tough word problem. So we've got a certain rectangle's length is 2 feet longer than its width. The area of the rectangle is 35 square feet. Find its dimensions. Ooh, so this is a factoring problem. So we're jumping right into factoring. Ooh, so it's a word problem and a factoring problem, both in one. So let's do it. I would draw a picture first. Draw a picture. What you got there? So a rectangle's length is 2 feet longer than its width. So I'm going to say width is x, and then length is x plus 2. Now, you do have to remember that area of a rectangle is length times width. So when they give me the area, I'm going to take x times x plus 2 and set it equal to what they gave me as the area, 35. All right. Now, you got to go back to chapter 5 and do the distributive property. X squared plus 2x equals 35. We don't want it equal to 35. We want it equal to 0. For right now, we want these things equal to 0, because then remember, the only way to get to 0 through multiplication is if one of our two is 0. So we've got this trinomial, x squared plus 2x minus 35 equals 0. All right, so now my favorite thing, factoring. So we are going to pull this apart into a first degree binomial times a first degree binomial. And to do that, we're going to look at negative 35. Okay, so it's like a little mystery. Negative 35, we build our suspect list off of that. Anything that multiplies to give me negative 35. Negative 1 and 35, negative 35 and 1, negative 7 and 5, negative 5 and 7. Now, some of you are really good mystery solvers and don't need to write this out. You can just look at it and say, oh, I knew that was positive 7 and negative 5. Don't pick this one. This is negative 2 when I add those together. This is positive 2. That is negative 34. That is positive 34. I need it to add to this and multiply to that. And so it is negative 5 and 7 in factored form. But wait, there's more. Because now I set the only way to get to 0 through multiplication is if this is 0 or this is 0. 0 times anything is 0. So x minus 5 is equal to 0. X plus 7 is equal to 0. And now I add 5 to both sides. X is equal to 5. I subtract 7 from both sides. X is equal to negative 7. So it's a callback to chapter 2 when we were solving 1 and 2 and 3 step equations. So that's why I said you have to get that mastered before you can go on. You see all of the things. Look at this. We got a little geometry in here. We've got problem solving. Okay, so now we still have one last piece. They want to know, well, what's the width and what's the length? Well, the width we identified as x, so we know that's 5 feet. It can't be negative 7. Negatives can't be lengths. So that's out, because that's called a domain restriction. Because it's a real world problem, there is no such thing as negative lengths. There is no such thing as negative time. And so we toss that away. And so then to find the other one, we put in our 5. 5 plus 2 is 7. So the length is 7. And you can double check it. 5 times 7 is 35. All right. So that was a pretty tough problem. That involved factoring. All right, so now now we're just in factoring mode. Remember, factoring is pulling it apart. So we've got all these different ways to factor. What did we have here? X squared, y to the third, and 22. Sorry, 22x squared, y to the third plus 18xy cubed. 18, yep. And now we look, we're trying to factor this. So first, there's only two things. This is not a perfect cube and a perfect cube, and so it's not the sum of cubes. It's definitely not the difference of squares. So then GCF, greatest common factor. So the biggest thing that will come out of 18, that'll come out of 22 is 2. The number 2. And if you didn't know that, you break down 22 into 2 times 11, it's primes. You can break down 18 into 2 times 3 times 3, it's primes. And then when you're looking for the greatest common factor, the GCF, you only take what they have in common. So they only have a 2 in common, and so that's it. The number 2. X squared or x, you always take the lower power thing. So x, y cubed and y cubed, so we'll take y cubed along. And that is my greatest common factor. So you write that down, and then you write an empty set of parentheses. Now, how do I figure out what goes inside those parentheses? Well, it's the opposite of the distributive property. So look up here, we did -1 times both of those. That was a distributive property. We're undistributing, and so, or factoring. And so instead of multiplication, we use division. So this divides nicely because those cancel, that's 9. This plus stays a plus, that came from there. and then the y cubes cancel, x and an x squared on top, so there's an x left. 2 into 22 is 11, and there we have it factored. That is it. Factored form, 2x y cubed times quantity 11x squared plus, or xy squared plus 9. All right. Okay, let's look at 23. Is xy plus 5y plus x plus 5. It's factor by grouping. They tell you to do factor by grouping, which is, again, when we use the AC method, that's how we finish the problem. So this one is a little tough, though. You wouldn't think it because it's like, well, these look like pretty easy numbers. Well, yeah, but look, y comes out of the first two, so you just look at the first two. And so what can I factor out of those? It's a y. So I pull that out front, do just what I did there, greatest common factor. And so that is x plus 5. But then on these second two, those are called relatively prime. They're prime to one another. There isn't anything that they have in common. But there is a default greatest common factor. Do you remember it? Do you? It's 1, the loneliest number. So we put that 1 down, we divide that by 1, we divide that by 1, and so then we end up with that x plus 5 again. And now you're not done. We did greatest common factor once, greatest common factor twice, and to finish any grouping problem, you're doing greatest common factor 3 times. And so this is like the biggest trick yet. We're going to factor out a binomial. So we write down the binomial, and then we get those to cancel, right? It's y times that. So as long as it's the exact same binomial and it's being multiplied by something, it cancels away. And so there's where the y comes from. And that cancels away. And that's where the 1 comes from. And then plus. Now, I've had students say, I don't want to write the 1. I'll just put x plus 5 and then I'll just write y plus 1. Yeah, that's fine. I like to put the 1 there, so you remember to write it down, because a lot of people cancel that and then they forget about the 1 and then they just write a y here and then they get it wrong. And I don't want you to get it wrong. So if you're good and you can just do that part in your head and just write y plus 1, that's fine. All right? Excellent. Smithers. Then I think we're going to break this into... I'll do one more factoring problem and then we'll cut it and we'll do one more video on the last 2 pages. All right. 6 and 7. Okay. So last one on page 5. It is, let's look at 24. We got p squared minus 24pq plus 80q squared. Jeez. So don't worry about the q, okay? We'll bring that in at the end. But 80, so we're looking for things that multiply to be 80. I want my list of suspects to solve this mystery for 80, but it's got to multiply to be a positive, but it had to be a negative. So you got to be smart about how you make out your suspect list. That means negative, negative. So -1, negative 80. -2, negative 40, -4, negative 20, -5, and did I do a suspect list there? -16. Okay, so now we look and say, do we have it? -81, -42, -24, we're under chicken dinner right there. And so you don't really have to keep going if you've got it. I didn't do -8 and -10. There are other ones that are out there. But as soon as you have it nailed down, you don't have to keep making your suspect list. You caught them. All right? So now we write out 2 empty set of parentheses, and it's going to be a binomial times a binomial. So p times p is p squared. I put down the -4 and the -20, but we're not quite done because they jazz this one up with a q squared. So we're going to throw a q onto there and a q onto there, and that'll fix it, because now a negative times a negative, positive 80q squared, and then negative 4pq, negative 20pq, add those together, you get that negative 24pq. And so that is factored. All right, the last video will be the last 2 pages.